Sweet. Okay, well, hello everyone. Welcome to the Data Science and Technology panel. My name is Natasha Bronstein, and I'm a senior in chemical engineering, and I will be the moderator tonight. I'm excited to introduce to you guys our three wonderful panelists. First, we have Nicholas Ivarson, and he is a instrumentation engineer at Capstone Technologies, and he graduated in 2016 from UW with Bachelor's in Chemical Engineering. Next, we have Khushmeen, which I don't know if I said that right.
Yeah, you did.
She graduated with a master's in science from our chemical engineering department with a focus in data science. And she is currently a machine learning scientist at BASF Corporation in New York. And then last but not least, we have Dr. Yeneneh, Yimer, and he got his PhD in polymer physics. And he did his postdoctoral research here at BW, and he is currently a senior data science engineer at Starbucks. So, I have a few questions for you guys. First, how many of you guys deal with large data sets? Few of you. How many do? Well, everyone actually. And I assume all of you guys know coding languages. Do you have anyone who knows Python, Java, R? R? Yeah, a lot. Sweet. So, well, this is definitely a panel for you guys. These guys work with data all the time, and I am very excited for it. So, we are starting a little bit later than planned, so I'm gonna have to ask you guys to keep your answers to a minute or less, if possible. And we will have time for the audience to ask questions. So please think of some questions. So to start off, I have a few introductory questions. I'd like each of you to talk about what your career path was and how it led to where you are today.
I guess I'll start. Short career path. I guess I graduated in 2016, but long ago I was actually a cook, where I did a lot of troubleshooting, things I like. There's always problems in the kitchen. There's a lot of optimization that you do. So I went into I did it like an internship at Capstone, but it's a small company where you put out a lot of fires. You have a lot of responsibility because there's not a lot of people do things, and so I really enjoyed that aspect of it. Accepted the position within that program.
Okay, I'll go next. I'm formerly a chemical engineer by training. I did my undergrad in University of Mumbai in India. I moved to the University of Washington to do my master's in chemical engineering, and I was part of DIRECT, which is from the Science Institute. If you don't know more about it, David Beck and Jim have led the program. I was also part of Jim's group, so that's where I started dabbling with Python. I got into DIRECT. But I was fortunate enough to have a mentor in PNNL when I did my Capstone project with DIRECT over there, and that sort of really gave me a good perspective about what it is like to work in data science. Outside, even though PNNL is a national lab, they have very good researchers from all over the world. And my thesis was also based on how I can use machine learning to predict properties of ionic liquids. So one thing led to another, and I've always focused on using data science and materials development or chemical engineering applications. And my first gig was at a startup in LA called TrueLab, and they do AI for drug discovery. And then I sort of got, I don't know, I guess scouted on LinkedIn or something, and BASF, if people who don't know BASF is the largest chemical company globally. They have a very big presence all over the world, and they are heavily investing into data science and using machine learning to accelerate chemicals discovery. And so this was a new and exciting group, and that's how I've led. It's come here, and I think UW is a great place for everyone to really, even if you've not been in data science, kind of go into that path. So that's my journey.
So my journey is, after getting bachelor in physics, I was a high school teacher for 3 years. Then I get my master's in statistical physics, and went for Europe for postgrad, and I was a lecturer, and then came for PhD to the U.S. University of Akron, Ohio, where I took Diploma of Science. And so after my master's, doing my PhD, I was doing high-performance computing and market simulations. And I became a postdoc at James Groves, trying and so in that case, just trying data analysis. And then I made the transition to the data science, more of the care path and passion. What drives me actually, I've never been satisfied. Since I think more, if I'm not challenging enough, I just want to move to the next one. And then I was data science, also as a manager of one of the consulting company, and then some of the recruiter from Starbucks actually reached me out from LinkedIn and they say, hey, I'm interested in it. That's the way I came to Starbucks. But if you look at my study, it's data science engineer. So I'm a data scientist working with engineers. So I will explain to you later, but more of bridging the data scientist to the engineering, the core engineering, where the key, because in data science, the model, actually how you make the connection and how you put the gap. That's fine.
Very cool. And now also an introductory question. If you guys could each describe what a day looks like for you. Day in the life.
I work on a lot of different projects. All ones are often very much smaller projects. 20 anywhere from 20 to 400 hours. And so a day, and then it's also a software company. There's a lot of support going on. So an hour of my day might be spent working with support engineers or actually on calls with customers directly, just trying to figure out issues where for some reason data has been cut off somehow, or they're trying to create something and they're able to do so. Another hour is probably spent in just a lot of project and people management, making sure things are in the right place, looking at the status of projects. And the rest of it, 6 hours of my day, 8 hours, 10 hour day, is spent a lot of it is coding and making computers are massively stupid things. They do exactly what you tell them to, and so making code and troubleshooting it over and over and over again until it comes up with an answer that works.
So my day-to-day, I would say 50% is obviously coding, getting my models to run, and I work as an in-house data science consultant, so it's my job to understand what BASF businesses are. So they are into agriculture, petrochemicals, catalysts, you name it. And it's our team's job to understand what we can do with the data and how can we make them more efficient and how can we kind of convert that to the dollar. So a lot of that is spent time touring labs, touring factories, understanding what their data looks like, and then figuring out what are the best models that we can build for them. And a lot of app development is also needed for that, because you can build a model, it'll sit in your Jupyter notebook, but how are people going to use it? So, how can you bring that? And then there's a team of software engineers, and like Yeneneh said, that how do we kind of bridge the gap? So since we know that, and most of my team is also from chemical engineering background, so we understand chemists, we understand what's going on, and then we have to like bridge the gap with the software. And then a lot of meetings. It's a German company, so early morning meetings every day. So yeah, that's pretty much my day.
So mine is, I play 3 roles. The first one is more of enablement side, where enablement in a sense, not all data science are equal. In a sense, they're good at the domain. Sometimes the technology side is lacking. So what are the best practices, how you use it, how you train it. So bringing a model, how you make it efficiently and deploy it and then consume it. And then also translating when it's a business, because I'm working service technology, I'm supporting the finance, the marketing. There are different teams who consume. And the second one is more of R&D, new technology, new ideas, bringing those with the team and build. And the third side is more of building the models. Sometimes on my own lead work and then can build the model, and which is consumable. So kind of enablement, also model development, and then also consulting in the sense of earlier when I joined Actwise, if you look at the Starbucks mobile app, if you use it, as part of the team, we built it in-house, where we applied SLS requirement from the previous the response time, the functionality. And most of the data science, what I did, the challenge is not building the model. The last mile usually, especially if it's a customer-facing program, that's where we're lacking. So that's why they made me to the data science engineer, bridge the gap between the actual code that they told you to the data science, so that the communication doesn't get worse.
Okay, my next question is, I heard you guys mention working with other people a lot, with other, as you said, some people have chemical engineering backgrounds, other people you're managing or under other stuff. What background, there's a lot of people in data science, what are some common backgrounds you see and how do you interact with them as a customer engineer?
A lot of what data science is often, we're talking about products, right? You're making products for the people consume, who don't know anything about maybe even the data or the model. You're kind of making something that kind of short circuits that, give them the information to make a decision. And so oftentimes it's working, at least for me in a support role, it's working with people who kind of have no idea what's going on. Like they don't know where the data comes from or where it's going. They just know this thing that they need to make a decision is broken. So oftentimes, so that happens a lot where you're working with, process engineers and things. But then also, I work a lot with IT people where we're talking about like where does the data come from and what lines does it really go across, or what servers is it hitting and why is it broken, or how do we hook it up, etc.
Yeah, so for me, I think it's very different, but most people definitely come from research. And we have chemists, chemical engineers, so we look at their data, so we obviously talk to them a lot. And then there's also people who don't have a chemical engineering background in my team, but are very good with data science and the field itself. So it's also my job to help them understand the domain. Like I explain to them, okay, like what are polymers, or what is happening in bioscience. So I feel that's also important. And I think it's also, a lot of it is like understanding, like you said, like if there's something wrong, what exactly is the cause of it. And then there could be problems in IT, so you're talking to them. There could be problems in just the data structuring itself, and maybe like somebody's framed it in such a way, and then you have to speak to them and get some things changed. So it's definitely, I would say, the more technical you are, the more difficult it gets. I think you have to learn to dumb it down a little bit. And I know in academia everything's all about equations, but nobody talks in terms of equations in the industry. It's always about how your model looks, how you visualized it, and how can you explain some data science to someone who has no idea about it. So I think that's something that if you could do or start practicing right now, it would be helpful later.
So for me, since Starbucks is more of the retail company, so in data science side, is you get people from statistics, some from the engineering side, and some from software background. But the way for me the unique position is because some of the leadership or business are more of finance or statistics, and the core engineering are more of the software. So the challenge is how do you get that bridge and then translate? Because if I start to go all the crazy algorithms. It doesn't matter to the leader, the CEO. The question is, what difference are you making in the sense of from business? Show me have vision in the sense of the bigger picture, rather than not how, tell me what you are giving me, and then you explain how you did it. Sometimes in science we tend to go to the deep and the process and then the crazy algorithm, like the fancy how great it is. Because they don't care the bigger, so sometimes getting that focusing and having a concise way of communicating, especially non-technical people. And leadership, they don't have time. They give you 10, 15 minutes. And you have to sell your idea. And if you don't get it, then. And for software, they say, hey, I know how to do it. And tell me what you need. And they don't want to hear your crazy algorithm. Just, okay, this is what they're out there expecting. And then you do it. And the data engineer, they tell you, okay, because you're getting data. When you say big data, sometimes petabytes of scale. Because the sales. So the engineer has to make those real-time data scanning and how you communicate with them, because you are going to maybe go to small data, and then when you scale, how you're gonna handle it. So it depends on which team you're gonna talk to. And so the best thing I learned from before you speak up with the team, ask them what they know about what they're about to talk. And then if they don't know, then tailor your communication to their need, rather than just blindly just saying what you think.
Yeah, communication is really about you instead of them.
Yeah.
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 Okay, I'd like to open it to some audience questions right now. Any questions? Sterling? Yes?
Yeah, so I was reading some of the the paragraphs on the booklet about kind of you guys' backgrounds, and it sounded to me that you guys are not coming from a traditional computer science background, with more like science and then transitioned into data science and that kind of stuff. So I kind of want to know how that comes about, and how do you decide from, say, chemical engineering BS, Bachelor of Science, into like doing something like being a data scientist. Yeah, how do you make that decision, and what motivates you into going into the field of data science?
You just follow the order.
Sure, yeah, that's great. I think college is great. It's you go into a degree, you get this degree, but it doesn't. It's not something that needs to crystallize you into a role. It gives you a lot of tools, which is why you find at these career fairs, finance people, business people, and everyone's trying to hire you, even though you don't know anything about their thing. It's because you have a lot of different skills. And so rather than coming from I'm transitioning from being a chemical engineer to a data scientist, rather than thinking about that, instead, what do I like to do? Who am I? What things make me happy? What things get me up in the morning? And then looking for the field that does that, and seeing what my experience maybe as a chemical engineer, but also all the auxiliary skills. How can I use those to get into that field? So yeah.
I think a lot of my motivation came from the background itself, my research background, what I studied in grad school. But I think the unique thing is definitely what you bring to the domain. You'll never find someone just coming, you'll find people coming from all kinds of backgrounds, like they'll come from biology, chemistry. They learn how to code, and then they bring their domain into the field, and that's what data science is about. It's about interpreting your models and your data for the people that use it. So if that motivates you, if predictive analytics from your data motivates you, then this is definitely a field that you should be in. If you enjoy something that's very fast changing, if you like a dynamic workplace, then this is definitely something that will motivate you, because the field is changing a lot. And I think it's just about, like he also said, it's about what you love. If you think this is what you want to do, and there's a lot of opportunity. The industry is really hot out there right now. You have the skills, you're in a good school like UW. I don't think there should be a problem for any of you to really go out there and make it that.
So for me, the transition is except the business IQ, more, even though my PhDs and my postdoc have high performance computing, so programming more of. I start with Fortran, and the programming language I love with. At least in data science, the core, anybody who's coming from science, the problem solving skill, you over the year of the process you made, you can't just get in one day. So that's your asset. Just focus on your strength. Don't bundle with the computer science that are good in algorithm, building technologies, but you're good at solving problems. That's where your core competence. If you go to the data science or in that domain, sell your strength, and then willing to learn and get dirty and pick up the technology. Technology you can pick it up. It's not that hard. But the problem solving, everybody wants you in the data science from the science background. That's key. So you're thinking process. And when I was talking to somebody who interviewed me, and he was explaining how the decision makers are doing my heritage. you can take the software 6 months of training, but you can't take that problem-solving physics because you can't send him back to school. So that's where you have to focus on. And why switch to data science more for me? I was an academic for long, so published papers, I was supposed to. More for me, the passion in a sense, having an impact. Because more of when you over-specialize, you narrow down, unless you've been successful in the career, academia, and bigger, maybe your impact is big. But for me, getting narrower, and my papers on the shelf, only the community knows me. But I say where I can solve the problem challenge it every time, and have a bigger impact and see. I haven't seen that rewarding when you work on data science, and you see after 6 months, your application's out, your customer satisfied. You kind of, for me, that's where it drives me to go to the data science. And then also, from data science also there are core domains where you have to focus on, like looking forward, like especially on the computer vision side or the deep learning side, where it's the core. The other one, if you say the other traditional data science domain, it's going to be automated in a couple of years. So your science used on the core technical problem where you can take a paper, read it, solve it, and implement. And then that's where I'll give you advice.
More questions?
What is the biggest challenge for you going from academic or switching industry and then doing something slightly different?
I think it's really important. Actually, Cynthia said something about this. Is that being comfortable in a place where you don't know very much, where there's a lot of informational ambiguity, is really important for every engineer. But it happens a lot because at least in my field where sometimes I'm talking to people that I've never spoken to before. I don't know the process. I don't know anything. I don't even know how they're set up in terms of how their data flows. And so being able, and I think engineering and science does a really good job about you always question your assumptions, but they became kind of at a much higher level where I had to really be better at asking the right questions and stop like looking at something and saying like, this is what I'm getting, but also asking like, why am I getting this? Or sometimes when someone gives you a requirement, rather than say like, yes or no, or this might be difficult, et cetera, it's like, why do you want to do that at all? Like, we can solve this problem a lot of different ways, or solve even more fundamental problems. So getting to that information and learning to think like that took a little bit more time, and that was a little bit more difficult. And then also, there's of course always imposter syndrome. I think it happens all the time. And so transitioning from chemical engineering, I went into I didn't know any programming, and so now every day I'm learning, and I'm also looking back at stuff that I've made, and be like, oh God, it's awful. And so and that can often feel like constant failure, like you're constantly not good enough, and that's of course not true. And if you're going to interpret those things as failures, then also dwell on them, that's a real issue. And so dealing with that in a healthy manner is difficult.
I think in academia, you're given one set, you're given a topic, you're given an advisor, your advisor is your key point of contact. But in a big corporation like BASF, you have a lot of different key points, key people you need to know, and it's only then your work gets done. So you're good at what you do and your boss knows that, but how do you kind of get that out in the big company? Like how do you kind of bring yourselves? I think that was a big challenge because like you're just part of a research group over here and everybody knows you and you're like the star over there. But when you're out there in the real world, you really have to like constantly network, even within your company. You have to sell yourself. You think you've done a good job, you've built this great model and it works very well, but that's not enough. You have to find a way to constantly improve, and that's also a big challenge because you have to learn as you do stuff, but then also market yourself in what you're doing and why you're making an impact in the company. So I think if you can start doing that right away, and if you know you're going to make the transition to industry, you want to make sure that you're constantly networking, you're constantly selling your strengths, and you are doing a good job, and letting people know that. And you shouldn't be afraid of or shy of doing that. You should be proud of it, and that's the only way you kind of advance in a big corporation.
So I think a couple of points. One, the culture is different. The corporate culture, each corporate is different. So knowing that dynamics is, and you have to know the game, how the org, how people work. People even jump in, and because people have been there for 20, 50 years, and you have to know which button and how to communicate. And in academia, usually you reward for your perfections, how good you work. And in corporate world, it's more of how good is what you do, and what the bottom line impact you are making. So it's not perfection. For example, if I say I have a model, it's not how good is the model, what incremental revenue, whatever change I'm making, what's going to cost me to implement. So you have to kind of an optimization program there. And the other one is when you go to those domains, data science, because you meet different people, and your business acumen is not good, especially when you're early joining the company. So you'll be uncomfortable and embrace that, and willing to learn, be dumb. It doesn't hurt you. It takes you a year or two, and then you figure it out. But if you pretend you know everything, and it's really hard to grow. So be dumb and willing to learn, get dirty. Good. If you know your core competence, you know what you don't know, and willing to learn, and people are willing to help you. If you are not willing to say you say I know, people are willing, and they say, hey, just So being comfortable and willing to learn, and especially in those domains, since you're gonna hit different people and then problems. For me, I came from academia, I went to retail, and I also, the previous work I worked in bank. So they're different mindset, different problems, and you have to talk to them and willing to, that dynamic is really easy. So willing to learn and listen, and then every time the learning curve, in a couple of years later you're an expert. In a sense, that makes you perfect, and it's always you grow because the technology change, the business is going to change. But be willing to learn and be dumb. Pretend. I just willing to talk to you because for me the challenge is in the group 2 or 3 people who have a PhD, and the moment I say I start to use, people not willing to talk to you. That's the challenge because they think you hard, and so I say no, just forget that. I don't know, just tell me. So.
You have more questions? Yes.
What was the process of finding your first, or finding and applying your first job like, and how did you kind of like market what skills you thought were most valuable?
I can talk forever.
Very poorly. In fact, I was quite surprised I got my first internship at Capstone and failed it. But I mean, it's a lot of preparation. So at these career fairs, I would go and I would come up with the things that I thought were looking back on it, maybe not so much, but going in and having an elevator pitch about yourself, right? About who you are and what you bring and what you can do, and then also at each different place trying to tailor that into like how it works with what you think they do, which should also be something you know. But it's a lot of legwork. It's a lot of applications. It's a lot of that stuff, and it's unfortunate. And so there is an optimization problem there in terms of how much time you're willing to spend. But yeah, and you want to think about the things that you do well and you want to sell. are kind of the two things that the Venn diagram that you want to draw, and then once you found those things, start talking about that you have them and how you show them.
Yeah, I think for me, I didn't have a PhD in something that I had so much time to learn. So for me, I was in direct and I had a very steep learning curve, and I had just 2 or 3 projects that I could talk about. So how do you market yourself when you've come from traditionally chemical engineering? And then I remember my first interview, I was at KPMG, which is a big consulting firm, and I was trying to explain to them how chem informatics can make them money. So they were like, oh, you've done a problem in data science, can you tell us how that would translate to the business or the dollar? So I was trying to sell them how like my chem informatics could do that to like a pharma industry, and then I used the same presentation for BASF, and it was completely different. It was more talking about features themselves, and the audience was right. So I guess like understanding what industry you're going into. So if you're going into retail, or if you're going into pharma, or you're going what do they care about data science? Do they care about the models you're building? Do they care about the features that you're using? Do they care what is it that industry cares about data science? So I think that took me a while to understand, and I gave a couple of interviews, and then I finally understood that different companies have different needs, and then understanding that and being well prepared when I go into the interview, what I should talk about, which aspect of my project would be most appealing to them. So I think if you already know you want to move into business later, you might want to start at least doing a project or thinking about like how can I make my PhD project sound like that to a data scientist in the industry. And just like practice a lot, and just don't be afraid of like being like I haven't had enough experience, because not everybody does, but they really appreciate you being able to talk about your projects well. So as long as you can do that, I think you'll be fine.
So if we proceed, the domain you are expert in is easy to say, but when you get out, like the data science, we're completely different than the academic setting. And for me, that answering wasn't easy to be frank, but it's not the technical skill, more of the business acumen and what they need from the technology side, from their program. Because they say, oh, always what they said that the early challenge had, you don't have industry experience. So what you have to do then, look at whatever internship or any project you did, try to connect that to their program. Try to talk to them to their language rather than expecting them to understand it. The challenge we're having usually we create that bubble zone and we talk to ourselves rather than understanding them and then translating what we did and explain to them how they can consume. And so what I would advise also, if you're early in the job search, first identify what you want as a career, at least entry level, and then and talk to people what skills required, and see what you have, and then try to work to bridge the gaps you have. And some of the interview I do, the person when they ask me, they say you have this, that. Sometimes they expect you to have longer list and to be expert. And honestly, what I told them, if I know all this, I'm not willing to come because nothing to learn from me. So you're not expected to be expert in everything. There are the core competency they require. Try to figure out and translate whatever skill and the work you did, and talk to them language. That's a key. If you start talking about equations, don't care. Right? How the program. And then, so for example, if you're interested in the bank, so what the bank finance they do, for example, they do forecasting, fraud analytics, and try to relate those, understand their language, and then try to relate whatever you did to them, kind of. So kind of bridging the gap is the key, and then also understand what core competency you have, what you can bring to the table. That's where it's my matter. So why should I have? Well, I have ABCD, and I can bring this, and I'm willing to learn ABCD. Then that's where transition wasn't easy, especially when you make a new move. But if for early 6 months or a year, figure out and do some extra project by yourself, extra time, and pick a mentor and people and talk to them, identify what are the key. Because for me, I kind of a bit late in when I was trying to search the job search, and I struggled a bit to work out, but make sure at least use the time and prepare it.
So kind of common theme. It sounds like, and I like both those examples was have the topics that you talk about are essentially the same. The way you present them and the story you make about them is different. And that story is very important because that story is how does this relate to you, or how does this relate to the employer. So being able to interpret yourself and reinterpret yourself and your experience in many different ways is kind of the common theme.
Okay, cool. So we are actually almost out of time, so I have one final question for you guys, and that is, what is the best piece of advice you guys have heard, and how has that impacted your life?
I mean, for me, follow your passion and be resilient and persistent, and the rest will make it. I mean, and first identify because if you follow your passion, that's and then being resilient and persistently follow your passion. Yes, there's hassle and ups and downs, but you'll reach. And then also believe in yourself. And most of the time, we undervalue ourselves. We doubt too much. And then say, I'm not saying be arrogant, but be confident. And you earn it. And then be confident about what you earn. And then if you don't understand, I'm willing to learn and push it. So persistent, follow your passion, and willing to learn.
I think it's being able to frame your failures correctly, or let's say not dwell on your failures. Every time this is one of the big problems in academic publishing right now is you don't want to publish a failure because that's or a confirmation that something doesn't work, because that's just it just doesn't sound really great, right? But at the same time, that's information. And every time you fail, every time you do something, you get a result, and you can use that result to it's a model. I mean, you're using that result to inform future behavior. So it's really easy to really beat yourself up about failures, and then in that stress and depression, to fail to learn, why that failure occurred, whether it was a technical failure or personal failure, et cetera. Not to learn and learn from that failure and then reapply it and ideally over time not make them again. Make better mistakes. You should always be making better mistakes.
Yeah, I think I echo with both of them. And another thing that I've kind of learned over the years, but I've also gotten advice, but is that kind of follow your instinct. Like sometimes you just know within like this is the path that you're going to take and this is what you'll be good at. When I started this whole data science realm, and I was going for my first internship, and I was telling Jim, I was freaking out. I was like, I don't know much. I don't know what I'm going to do at this internship. He's like, you'll be fine. Just follow everything. And then I think 2 weeks into it, I kind of already felt like instinct, okay, it's good that I came here, and it's good that I was here, because when I went back to my research group, I actually had learned so much that I could even teach my fellow graduate students. So I think just follow your instinct, and if you're at the right place at the right time, you just work out pretty much.
There's one point is further. We tend to live the past. For me, whatever happened in the past is past. Take a lesson, move forward. So whatever in your career or your job, whatever, if you fail, I failed, this is the best lesson, move forward. Take as a positive feedback rather than regretting, and I wish I could have done this, I could have. You cannot change, past is past. So you look forward. And from those lessons, why did I fail? And then say, oh, I should have done ABC. And they say, rather than I should have done it, okay, next time I'll do it again, I'll be better off. So take that key past experience to prepare you for work. That's a key, because don't leave, say, failure, I failed how many times? But wake up in the morning, move forward.
The supreme irony here is that data scientists are telling you not to dwell on the past. But in personal life, not personal.